Alright, so this is lesson 2, and it is an introduction to C++ and the use of arithmetic. Alright, so what happens is that we have that basic thing, which is the basic structure of C++, meaning to say that there must be a header statement and so on, right? Then we look at manipulating things inside C++, which is getting numbers and calculating by way of plus, minus, multiplication, division. So it's fairly simple. Basically, you just need to know the symbols first, of course, right? So we have this symbol for addition, this symbol for subtraction, this symbol for division, and this symbol for multiplication, right? And then you're set, right? So before we can actually manipulate something from the user, meaning the user is able to give us something to manipulate, to calculate with, you need to declare a variable. What is a variable? So we have this thing called the RAM, random access memory, in the computer, right? And the random access memory stores many things, but there is also quite a bit of space, empty space on the random access memory, usually for most computers, most modern computers. And because we want, when the user gives us something, a number or something, because we want the number to be consistent, we don't want to just store it at any random location in RAM and then later not be able to retrieve it. We want it, okay, I want to put it here, and whenever I say take the content of whatever is in here, then it's definitely that thing, not something else. So what we do then is to name it, meaning we name a box something, then we put something in the box, then if we call, I want the content of this box, so it will consistently be that content, it won't be just a random box, right? So declaration of variables is just naming the box. Let's say, for example, you name a box A, B, C, for example, right? Let's say you name this box A, right? This name A, and this name B, for example, and this name C, right? So this is the declaration. It's just something like that. You just name the box. So later, when you can do something like this, A is equal to B plus C. So whatever the user decides to supply to us, we say commit this value to B, commit this value to C, right? And then we can manipulate those values, right? And then we won't just take a random box and add it and then give the value to A. So this is declaration, right? So to be able to do arithmetic, we have to declare variables and then call upon the boxes, call upon the contents of the boxes to do those arithmetic calculation, right? Arithmetic operation, sorry, right? Understand integer and floating point numbers, write arithmetic expression in C. So these are the goals of this particular chapter. Appreciate importance of comments and good code layout. So it's very important to put comments because then you know exactly what you're trying to do. Because sometimes we are trying to do something in C++ or whatever kind of programming language, but we did not actually, we don't actually succeed in doing it. Having comments, at the very least, make sure that this is what I'm trying to do. If we don't succeed, then at least we know this is what actually I was trying to do, but no, I failed, right? Or in the case of us having very long programs, a lot of times, let's say for example the program is worth 1 million lines of codes, right? So if we divide it amongst ourselves, the 6 of us will have around 180 million or something, 170 million. 170,000 lines of codes each, right? In order for us to get to that 1 million, right? So with that, it's important to use comments so that whatever I'm saying, whatever I'm doing, is clear to everyone else in the team, right? So this is comments. To be able to define initialized variables, so define an initialized variable, recognize limitations of the integer and double types. And then to be able to change the values of variables through assignment, meaning something like this. This is by assignment. Alrighty. So what are variables and number types? Variable is the storage space, right? Which could be a number, string, or even a list of numbers. We look at number data types. So here, the number x is equal to the value 2 into the box called x. Right? So we just name, but before we can do this, of course, we have to declare that there's a box called x. Right? And then we just say inside the box called x, commit 2, put 2 inside. Right? So see how the value of x is, and then you can just use it. So basically, this is the statement, this is a passive statement, whereas this is calling upon a variable. Right? So we'll output the value of x is 2. The first line assigns the value 2 to x, referring to x will look up the value 2. Right? So referring back to x, referring back to, meaning calling here, this part here. Right? This part here is calling upon the value x, calling upon the value inside the box called x. Right? So everything is ones and zeros to a computer. Numbers are represented in binary, so we discussed this last 2 weeks. Right? So we can also represent decimals. The longer the number, the more bits it takes to represent. Right? So with regards to the computer, it will then categorize numbers into integer, double, long integer, float, and so on. Right? So number 0.0001 takes more bits to store than the number 2. Right? So 8 bits, 1 byte. So again, something that we've covered before. So save memory, we want to use as few bits as possible to represent our number. Right? So the most common one would be integer and float, as seen here. Ironically, we can actually use the most bits, 32 each. Right? But if we go further than that, we have 64 and 80. Right? So if we don't actually indicate, then just to be safe, more often than not, the computer will take the longest one. Right? Although it's no problem for today's computers, which has much more space on RAM and hard disk drive. Right? Generally speaking, we would like to save space. So we use, we indicate that it's an integer or float in order to use only the necessary space and not much more than that. So before we can use a variable, we need to declare it. So declaration is just like this: integer x. If say we have 3 integers, a, b, and c in this case, for example, right? So we just say integer a, b, c, and then semicolon, right? So separated by comma and then semicolon. This is one way of doing it. If you want to, for some reason, if you want to do it like this, can as well, right? This is also not wrong, right? But needless to say, this is the more efficient way of doing it, right? A, B, C, that. It's just that sometimes we do it like this. When, for example, we want to use a first, right? So integer a, so we have a few lines of codes. A somewhere, A here and there, right? And then, you know what? I need another variable B and C. So then we declare again. This is fine as well. Right? So there is no exact location to put this declaration. It's just that you have to declare the integer before you use it, right? If you declare it here, you cannot use B here. So this is not right. Right? You have to declare first, then only you can use it. If not, most compilers will complain. They might be compilers which do not. Right? So before you use a variable, we have to declare it, choose a name and a type. A, B, C are not bad names. Same with X, Y, Z, and whichever terms. These are not bad names at all. But it is usually a good idea to have a name which is indicative of what you're going to use the variable for. Right? Let's say if your program is about calculating the circumference of a circle, right? So you're going to ask radius from the user, right? So it might be a good idea to name the variable radius. Right? So as good practice, try and name the variable which is indicative of what the box is actually going to store. Right? So that's it. Allocate memory for the variable based on the type that we assign, right? The X and Y. Initialization, we can assign the variable a value in the declaration. So you can assign a value as well. Again, this can be a good practice because sometimes when you don't assign a value and you made a mistake of displaying the variable before actually committing a value to it, then you might get very weird numbers, which is already, because when we name a box, the box need not be empty. The box might already have a content, and then we name it. So if we immediately use the content of the box, it might be some weird number, right? So it might be a good idea to initialize once you declare. But this is not a big problem, it's just good practice. Right? So be careful what values you write into a variable. If you, for example, if you declare integer and then you give a float value. Float is a value with a decimal point, right? Whereas if you declare a float and then you give an integer, right? Normally it's fine. Most compilers may not give error, it depends on the compiler. Most of the time it's fine. Most of the time it won't complain or crash or anything. But it's not good practice, right? So integers can have low decimal, fractional part, while floats and doubles require fractional part. Right, so rules for choosing, you can choose any name you want as long as it does not coincide with a set term in C++. For example, reserve word, in other words, right? Cout, return, these are all what we call reserve word, meaning it actually has a function, already has a function in C++. Right? Must start with a letter, it can contain numbers. For example, X3, way too cool, revenge of the next part 3. So the number can be anywhere but the first letter. The first letter must be a letter. The first character must be a letter, A, B, C, D, Z. Right? No spaces, but we can change capitalization or use the underscore, right? So you can use underscore, you can use capitalization anywhere, right? So these are the rules of creating a variable name. It's case sensitive. If you name a variable radius, whereas when you use it, suddenly you say radius with capital R, right? Then the compiler will complain, hey, I don't recognize this, right? So it's case sensitive. Three different variables. So these are three different variables: percent versus all caps, percent versus P capital percent, right? So these are three different variables. Right? So guidelines for choosing variable names still usually start with lowercase letter. Yeah. Here I give you freedom. I won't really restrict you to anything. Right? Better to use distributed variables, number of forms, right? Versus using n. So use a variable which is indicative of what you're trying to do. Except for counters, all variable names should be at least 5 characters long. So this is good practice, right? Not really, you won't be assessed and say, this is bad or anything. You won't get minus marks or anything, but it's good practice. Alright, so example here, how much is 8 eraser, 4 pencil, and 3 pen, right? So, so here it would be hard to keep track of the variables with these names, x, y, and z, right? So what is x, what is y, and what is z? So you might want to, instead of this, you might want to give names which are indicative, right? Eraser, pen, pencil, something like that, right? And then you get a total value like that. So this is easier to follow. Takes a little more typing, of course, but a lot of times our flow of thought is much more important than whether or not we spend more time typing. Meaning X, Y, Z can be, you simply just type X, Y, Z, but then our train of thought might be messed up once we, get to the more advanced section of this program. So total value direct. Then we get a total value. So what happens here is we'll just have a 3 integer variables, eraser, pencil, and pen. So as you can see, they are assigned values here, right? Then we have another variable called float total value. Total value is a float type variable, and then we'll just multiply. Here I assume these are the prices. Eraser is 50 cents per piece, 80 cents for pencil, and 150 for pen, and we just multiply that. And Cout total value, this is the text, and then the value, total value will be displayed right after that, and then we end the program, right? So here, whatever is multiplied here will get stored inside the box containing the float, which is called total value. Right? By the way, it's okay to continue a statement to the next line. Statement ends